Hello friends, welcome back to my YouTube channel MS Maths. In this video I will discuss divergent sequence, oscillating sequence, its important result and some examples based on these topics. So this is the sequence of real number part 4. You can watch all these parts in my playlist at YouTube channel MS Maths, and this is helpful for IIT JAM, CSIR-NET, GATE. My name is Manoj Solanki and I will start the topic. Even though you can watch the basics of real analysis in that playlist, go to the MS Maths YouTube channel and just watch the video. If you are really getting the concept and whatever I was discussing, if you are feeling that it is helpful, then you can like the video, share the video, and subscribe the channel to get more and more notification about the channel. Let's start the video. So first of all, I will discuss divergent sequence. What do you mean by divergent sequence? So for that, we have also seen that what is the meaning of convergent sequence. If I have any sequence an as n tending to infinity, is it really going to finite number? No, it is not going to finite number, then it is not the convergent. So that's the simple criteria here, that we are discarding sequence is not convergent. It means this sequence is divergent. So what do you mean by the divergence? So a sequence is said to be divergent to infinity. Okay, there are two cases here. One thing is that if it is 0, it is plus 1 and it is minus 1. Either my sequence will be the divergent to infinity or divergent to minus infinity. Okay, that we'll discuss two types of definitions here. Okay, first, divergent to infinity. A sequence is said to be divergent infinity if if given any k belongs to R, there exists n naught belongs to natural number such that any of an which is greater than of that k for every n belongs to this number. Or we can easily say that if my terms of sequence are going to the infinity, it means this an is going to infinity as n tend into infinity. That's what my sequence is divergent. Okay, I can take the example. That's what I have earlier written here. Simply, it is what 1. If I will write the sequence, that is 1, 2, 3, okay, 4, and it will go up to what? Up to 1000, up to what? Up to infinity. That's why if it is going to infinity and what? Plus infinity. This is tending to. It's not actually infinity. It's tending to infinity or plus infinity. It means it is divergent sequence. More example we can take, that is n square. It is also going to plus infinity. We can take one more example, that is what? Minus 1 power n into n. This is also what? It is nothing but minus of 1, 2, minus 3, plus 4. This will also go to plus infinity only, that we can say. Okay, but here in this case, if it will be minus 1 power n, now is it really going to the plus infinity or minus infinity? Because we don't know that infinity is odd or even, so we can't make any statement here that it will go to plus infinity, because we are discussing what? Divergent to plus infinity. Okay, but here it is, we can't say that it will go to divergent of plus infinity. It may go for infinity, because if infinity is odd, in your case that will be minus infinity. If will be infinity is positive, like even, then it will be plus infinity. So we are not able to make any statement right now here, but it is a divergent sequence. That's the confirmed thing. Okay, next we have note points. That diverges to infinity means unbounded above but unbounded unbounded above but what sorry yeah sorry So diverges to infinity means that it is what? My sequence is unbounded above. Let's say it is what? 1 to infinity. It is starting from 1, going to infinity. It is unbounded above. Bounded below is that. Okay, it is a bounded below. Bounded below means there exists a number which is, see, if it is 1, there exists a number which is less than of this particular n. And from all those numbers, this is my one of the greatest number. So this is what? Bounded below, but not bounded above. So it is called unbounded above. There does not exist any kind of number which will bound from upper side. Okay, that is something called bounded above. Then my sequence will go to positive infinity or the diverges to positive infinity. Now at the same case, if my sequence is something like this minus of n, it means that it is what, minus 1, minus 2. Now you can see here it is minus 1. It will go to minus of infinity. Here it is what, bounded above, but it is what, unbounded below. This is the case here. Okay, so now these are the some results, and these are some these are the definition of going to positive infinity and minus infinity. Again, minus of n square will also go to minus of infinity. Okay, next we have oscillating sequence. What do you mean by oscillating? Oscillating is something like that which will resume or which will oscillate from one point to another point. The sequence will attain this term, again attain this term. Okay, this will oscillate between these two terms. So whatever the thing, I can take one example, that is minus 1 power n. It is simply what, if my n is odd, then it will be minus 1. If n is even here, then it will be 1. So it means my sequence will be minus 1, 1, minus 1, 1. Will never go to 0, it will never go to infinity, or it will never go to any of the finite number. Because of that, we don't know how infinity will behave. Infinity will be odd or even. That's why we can't make any statement. So it is a oscillator sequence. Okay, this is the one of the example of oscillating sequence. But the thing is that which is neither convergent nor divergent, then we can say that it is the sequence which is oscillating. Something like this, minus 1 power n into n, it is again also going to be oscillating sequence. That's what we can't make any statement that it is going to plus infinity or minus infinity or whatever. Okay, now we have some result over here that a sequence an is convergent to plus infinity every subsequence of sequence. That we have already discussed the concept of subsequence earlier. What do you mean by subsequences? If you have, let's recall the subsequences thing. If you have any sequence an, and if you are making a n1, a n2, okay, a n3, these, let's say if these all are the sequences, subsequences, it means my n1, n2, n3, these should be strictly increasing. Oh, sorry, it should be strictly increasing sequence. These n numbers like 1, 2, 3 strictly increasing, then we can say this is the subsequences. So it means here it is a sequence an is converges to infinity, then every subsequences of sequence an is converges to infinity. It means a sequence converges to not, oh yeah, we can say it is not converges to infinity, it is diverges to infinity. Sorry, we can converges to infinity, that we can make divergent. We can make this term as divergent. Converges to infinity means that it is tending to infinity, not convergent. The convergent mean word is wrong here, or not bit wrong. We can use for whole this term. Converges to infinity means that diverges. So if a sequence is diverges to infinity or positive infinity, then every subsequences of that will also go to the positive infinity, or will also diverges to positive infinity. And again, this is the same result holds for minus infinity. Let's say one example, n. If it is a sequence n, 1 second, yeah, you can write here, so that if I have a sequence that is n, what are the subsequences that I can take? 2n, okay, 2n minus 1. It means that I can take if it is 1, 2, 3, 4 up to infinity, then it will be 2, 4, 6 odd, or only the even numbers. Then it means what? It will also go to positive infinity. It will also go to positive infinity. If I will take 1, 3, 5, 7 over here, then it is also going to positive infinity. This is what the thing that we are understanding here. So if we will take minus of n over here, then also it is what? Going to minus infinity. So here it is going to minus infinity, and all these subsequences of this minus n will go to minus infinity. Okay, next we have a monotonically increasing sequence is either convergent or diverges to infinity. It means that a monotonically increasing sequence. Monotonically increasing sequence means, let's say this is what this is monotonically increasing. This is, yeah, this is monotonically increasing sequence. It is also strictly increasing sequence. Similarly, the monotonically decreasing sequence, you can take the example of this monotonically decreasing sequence. Any monotonic sequence either converges or diverges, not oscillate. Every monotonic sequence. This is what my monotonic sequence. Okay, let's say this is what? This is again my monotonic decreasing sequence. Monotonically decreasing sequence. It is also, it is converging to zero. It means every monotonic sequence either convergent, divergent, nor oscillating, but it will not oscillate it at any cost. This is all about the result and the definition of the what we have discussed, the divergent and the oscillating, and these are some results over here. So thanks for watching my video. Keep watching MS Maths. We'll meet you in the next video. Take care. Thank you. Bye bye.